Hello everyone, welcome back. Today is going to be our test review, and this video is going to focus on reviewing all of the different concepts that we have covered so far in Chapter 1 or Unit 1. All right, this video is going to be kind of long because I am going over a little bit of everything, and I would recommend the way that you do this review is to download the blank version of that paper review and just work through it. See which ones you know how to do, which ones you don't know how to do before you watch this video. All right, and then come back to the video and watch the parts of the video that you need, right? You don't have to watch this entire video. So if you feel like I already know how to do a plurality, I already know how to do Condorcet, I don't need to see that part of this video, then fast forward through that and go to the parts that you do need. All right. Once you're done working through the exam review, you can also download the handwritten key that I put on MyOpenMath, and you can check your answers against that as well. All right. If you notice that I've made any mistakes, send me an email and let me know. I do make mistakes on these problems too, so I might have miscounted something or missed a winning coalition or something like that. So it happens, but just let me know if you think I've made a mistake, and we can try and figure that out. All right, so let's start off with the first problem here. We have an election that's being held to choose the president of Math Anxiety Club. All right, so there are 4 candidates: Andre, Bethany, Chris, and Derek, A, B, and C, A, B, C, and D for short. And it tells us right off the bat there are 71 members of this club. So it actually saved me a little bit of work here, because when I look at the preference schedule, I know the total number of votes now based on what they said in the problem. Okay. So ties are not allowed on individual ballots. The 71 ballots submitted are summarized in the following preference table. So here we go. All right, so one of the questions on the test, obviously I'm just going to see if you know how to read a preference schedule. So if I give you one of these, could you tell me how many voters voted in the election? Well, they told us that at the beginning, so that's just 71. But another way that you could find it is to go and add the numbers here at the top of the preference schedules. Okay, so how many votes are needed for a majority? So you have to remember the definition of majority is more than half. All right, so it can't be exactly half, it has to be more than half. So when I do 71 divided by 2, right, so if I took 71 and I divided by 2, let's see what we get here. Pull up my calculator. You see we get 35.5. So to be more than 35.5, I would need at least 36 votes. All right. Now the plurality, what they're asking for here is what is the minimum number of votes that you would need to win a plurality? And this is where you have to kind of think a little bit more abstract, all right? So recall that a plurality winner is simply the person that has the most first place votes. And we're trying to figure out what's the fewest number of votes you could get away with and still win a plurality. So remember, we have 4 candidates here. Okay, and the way that I like to start these off, I like to take the number of votes that we have and divide by the number of choices. It gives me a good starting point. So when I do 71 divided by 4, I get 17.75. So I'm going to start off with 18, and let's say this is going to be my plurality winner. Okay, so if this is my plurality winner and they got 18 votes, that means the other 3 candidates couldn't receive more than 17 votes, right? Because if they did, then they would either have as many votes or more than the person that I'm trying to make the plurality winner here. So if this one is my winner, then the other 3 can't have any more than 17. Now when I add up all of these votes, if I do 18 plus 17 plus 17 plus 17, I get 69 total votes. But remember, we had 71 people voting. All right, so if those other 2 people that vote for any of these guys, well, then we have a tie for plurality, which means he's no longer a winner. All right, so we have to up it to 19. So if I go 19, right, then this person could have at most 18. Well, that's 37 votes. This person can have at most 18 votes. Well, if I do 37 plus 18, we get 55, which means there's 16 votes left. right? So I would give the other 16 to my last candidate here. And what that tells me is that 19 is the smallest number that I can get away with for a plurality vote. Okay. Now it says find the actual winner under the plurality method. No problem. That's really easy to do. I just got to go to the actual preference schedules here and add up the number of first place votes that each person got. All right, and you'll notice the one with the most is going to be A with 25. So if we just did a straight up plurality, A would win with 25 votes. If you look at B, B got 19 and 2 there, so they would get 21. D got 10 and C got 15. Okay, so there's our plurality vote. So let's try a more complex voting system. Let's try an instant runoff. All right, and if you recall, the instant runoff method works by rounds. All right, so we're going to say round 1, we've got A, B, C, and D. And if I count up the total number of first place votes for each candidate, A got 25, B gets 21, C gets 15, and D gets 10. All right, and what we do after round 1 is we eliminate the candidate with the least number of first place votes. So I'm going to eliminate D. And then we go retally the votes as if D were never on the preference schedule. So if you need to, you can go back up here to your preference schedule and cross out candidate D. Just get rid of them. And then retally. Okay, so A, if I go and count up the first place votes for A is still going to have 25 after round 2. I'm going to zoom out a little bit so we can get that on the same screen. There we go. And then we're going to go to candidate B. B is also going to remain unchanged with 21 votes. Right, so I'll have 19 and 2 there. Now C, going from round 1 to round 2, the 10 votes that were for D are going to C now. You can see that here in the preference schedule. So now C is going to have 25 total votes, which means B has the least. So B gets eliminated next, and then we go to round 3. Okay. And I'm going to go up here, I'm going to cross off all the B's. And then I go through and I retally. So if I count up all the first place votes for A after eliminating B from the preference schedule, A still has 25 votes, and C is going to have all the rest at 46. Okay, so that means C wins the IRV. Okay, so that is an instant runoff vote there. All right, one of the other methods we learned about was called a board account. All right, so the way that the board account worked is you would assign points for your position on the schedule. So if you were first place, if you were last place, you would get 1 point. If you were the next place, you would get 2, 3, and then 4 respectively, right? So in a 4-candidate election, a first place vote would get you 4 points, and then it would work down from there, subtracting 1 point for each place you go down. All right, and then the way that I taught you to do this was to use a little bit of lattice multiplication to quickly calculate the points that each candidate would get for their position on the preference schedule. So for instance here, B, to calculate the number of points B would get for being here on the preference schedule, well, that represents 19 first place votes, so you would do 19 times 4, and B would receive 76 points for that position. And then we would just work our way across doing that for each one. So what I would recommend you do is just go ahead and pause your video if you haven't done this one already, and you can check your answers here in just a second. I'll get them all written down. Okay, so I've gone through and I have multiplied all of my boxes, so I've got all my points assigned here. And now what I would do is just go through and tally up all the boxes that had A in it, right? So A would get 19, 10, 15, 2, and then up here it would get 100. So if you add those boxes together, you should get 146 points for A. And then you would do the same thing for the other 3 candidates. You would go and find all the B boxes and add up all of the points in the B boxes, and then the same thing for C and D. And these were the point tallies that I got. So I got 199, 159, and 206, which means that D would be our Porta winner. Okay. And if you notice so far, we've done 3 different voting methods and we have 3 different winners, right? So A won plurality, C won IRV, and D won the port count. All right, so we're gonna keep going here. You might remember the next voting method, which was Copeland's method, and this is the one that looked at every single one-on-one matchup. All right, so make sure you don't miss any of the one-on-one matchups. That's probably the most common mistake with Copeland's. So I like to list them systematically, so I'm going to go all of my A matchups first. So I'll do A versus B, A versus C, A versus D, and then that would be it for the A matchups. Then I switch over to B. Right, so I do B versus. Now I don't need to do B versus A again because I already got it here. So I'm going to go B versus C, B versus D, and then that's it for B. So then I move on to the C. So I'd use C versus. Well, I got C versus A. I got C versus B already. So all I need is C versus D. And there are all of my possible one-on-one matchups. Now what I do next is I go through and I say, okay, well, let's just do A versus B directly. And you'll notice I made this preference schedule so that A was at the bottom. So it should be really easy to calculate. A is going to lose all of these columns, right? So we would do the only column that A will win is the last one. It'll win it every time because A is at the top with 25. So the score here is going to be 25 to 46. B wins. So I'm going to say B gets 1 point. All right, so remember, if you win a head-to-head matchup, you get a point. If you tie, you get half a point. If you lose, you get 0 points. All right. So then we would do A versus C, and it's going to be the same thing here. A loses to C in the first 4 columns, but A wins in that last one. So it's going to be 25 to 46 again. But this time C gets a point for winning. Okay. And then A versus D, it'll be the same story, right? Because A is at the bottom. So A loses all the first 4 of those columns and wins the last one again. So it'll be 25 to 46. D gets 1 point. Okay. And then we go to B versus C, and you'll look at, okay, well, B wins this column because B is higher than C for these 19. B loses this one and this one, but B wins here, so that's 21 so far for B. And let's see, so B loses that one. Yeah. So B loses 1, 2, 3 of them. Nope, B gets these 25. Okay, so 25 and 21, that's 46 for B, which means C will get the other 25 and B gets a point. There we go. All right, so then B versus D. When I did that one, I got 36 to 35. Again, feel free to check my numbers here. But B gets another point there. And then C versus D, I got 17 to 54. Right, 17 for C, 54 for D, so D gets 1 point. And then I'm just going to come over here and use this free space to tally up the points for each candidate. Right, so A, I don't think won any matchup, so it would get 0 points. B won 3, C won 1, and D won 2. And there you go. So B is a Copeland winner. Okay. All right. Now, the next question is there a winner by Condorcet method? And there is a winner by Condorcet method, and I don't have to do any work to figure that out because I have every single one-on-one matchup here for the Condorcet method. So remember, to be a Condorcet winner, you have to beat everyone else one-on-one, okay? And so I'm looking at B because they were a Copeland winner, and I'm looking here in this matchup, B beat A, in this one B beat C, and in this one B beat D. And those are the 3 wins that they need, right? So I can see those 3 wins in the Copeland results. So B is also a Condorcet winner. All right, last voting method that we learned about was called approval voting. And the way that you do approval voting is you have people check off the candidates that they don't mind, right? So if they don't mind that candidate winning, they would check them off. And so there's not usually a preference schedule in an approval voting type situation. Instead, you just list the candidates and those people would check off the ones they're okay with. So when we look at this type of a setup here, what we're seeing is that there were 8 people that were okay with A, B, and D. Okay, but I like to go across the other way, so I'll tally up all the approvals for A going across horizontally. So 8 people approved of A here, 7 here, 4 here, and 5 here, and I would add those up for 24 total approvals. Okay, then I would do the same thing for B, right? So B got 8, 6, 3, and 5, and I would add those up for a total of 22 approvals. And then I would do the same thing for C and D. So we got 18 and 20. 18 and 20, and A wins the approval vote. There we go. All right, guys. Let's go to the next problem here. All right, so here number 2, we've got a high school that is planning to vote for a new mascot. They've got 25 students who were selected to vote, and the preference schedules are listed for us here below. All right, so if we were to use the plurality method, so the first thing you want us to do is to do a plurality method. So if we look here, Wildcat got 7 votes, Bulldog gets 8 and 5, so that's 13, and then Pirate gets 5. So Bulldog wins plurality. Right, and then the question is it a good choice? Well, we've seen this situation before where you can win the plurality vote. We saw it in the last example too, where if you win the plurality vote, you could still be last in every other preference schedule. So Bulldog wins in these 2, but is the least liked among the other 12 voters who did not like Bulldog. So they would like anything other than Bulldog. All right, so I don't know if it's a good choice because Bulldog is still a very objectionable choice based on the layout of these preference schedules. All right, now if we tried to do an instant runoff vote here, let's see what happens when we do an instant runoff. Remember, this is where we go round by round and we eliminate the person with the fewest first place votes. So we're going to say round 1, we do, let's say, I'm going to need more room. I did not give a lot of room there. So we'll write it over here. So we'll say round 1, and I'm going to abbreviate these. So we got W, B, P, and R. So W for Wildcat, B for Bulldog, P for Pirate, R for Royal. And I believe it went 7, 13, 5, and 0. Right, so that means R would get eliminated first, right? They had the fewest first place votes, so R goes, and then we go to round 2. So before I go up to round 2, I'm going to go eliminate Royal from all of the preference schedules, and then I'm going to retally. So I'd say, well, Wildcat still has 7 first place votes, so I'll just write it across here, and then Bulldog's still at 13, and then Pirate goes to 5. Still, right? Nothing changed because Royal had 0 votes, so none of the first place votes need to be reallocated to any of the other candidates. But now Pirate gets eliminated. Okay, so Pirate is going to get crossed off all of my preference ballots here, so they're gone. And then we go to round 3, which only leaves Wildcat and Bulldog, and then we go through and we retally here. So Wildcat has 12. Now, because those 5 votes that were for the Pirate are going to the Wildcat, and we can see that here, right? So when Pirate got eliminated, that moved Wildcat to the top of the list, and so Wildcat will get those 5 votes. And Bulldog remains at 13, which means Bulldog wins. Okay. Now, another thing that you might have noticed right from the beginning is that we really didn't need to do all of this because remember, an IRV runs until somebody has a majority of the first place votes, which Bulldog had right from the get-go because Bulldog had 13 of those first place votes, that is a majority of the 25 total votes. So Bulldog had a majority, which renders the IRV useless. You don't have to do an IRV if somebody has a majority of the first place votes already. They'll automatically win every single round as you go through. Okay. You'll also notice that the same thing happens when we try and do a Condorcet. Right, so if I were to use a Condorcet method on this particular voting situation, we would look at the one-on-one matchups. So like if I did Wildcat versus Bulldog, right? We know Bulldog got 13 of the first place votes, and they were last place in all the other ones, so it'd be a 13-12 situation, and B wins. Right, and then if I did Bulldog versus the Pirates, it's going to be the exact same situation. Bulldog had 13 first place votes, which is a majority. So even if P won all of the other ones, which they do, and they got 12 of them, B wins. Right, and then the last one-on-one matchup would be Royals versus Bulldogs here. And again, Bulldogs would have 13, and the Royals would get the rest, and the Bulldogs win. So that means the Bulldogs beat everyone else one-on-one automatically because they had that majority vote. So Bulldog would win Condorcet. So it's not looking really good, right? Bulldog won the plurality method. They had a majority vote. They also won IRV. They won Condorcet. And they were also the most objectionable choice that was on that preference schedule, right? They had a majority of first place votes, but everyone else hated the idea of the Bulldog mascot. So none of these voting methods are assured at producing the least objectionable except for one, and that is the board account. Okay. All right, let's take a look at number 3, and this is where we get into the weighted voting situation. So remember how these weighted voting situations are written out. That first number that we see is the quota, and then each of these numbers are the corresponding weights for our 4 players, A, B, C, and D. All right, so the first question they might ask is the coalition formed by A, C, and D a winning coalition? Right, so if I write this out, A, C, D, and I go and I tally up the votes here, right? This is A, B, C, and D. Well, A, C, and D would have 10, 5, and 3, which is 18 votes. I then check the quota, which is 13, so 18 is more than 13, which means yes, it is a winning coalition. Okay. And then we talk about which players are critical in a weighted voting situation. So if I look at ABD, I'll write this out again, ABD has a total of 20 votes, right, between all of them. So the weight of this coalition is 20. So to be critical in a coalition, it would have to happen such that if you left that coalition, you would go from a winning coalition to a losing. Right now they are winning because they have 20 and the quota is 13. If A were to leave, they would lose 10 of these votes, dropping them down to 10 total votes, which would be less than 13. So A is critical. They have to have A in this coalition to win. If we lost B, right, they would go from 20 down to exactly 13 because B had 7 votes. So B is not critical. A and D can carry the coalition by themselves without B. And then same thing with D. D only had 3 votes, so if we lost 3, that would drop us down to 17, which means A and B can carry the team by themselves. So the only one that's critical here is player A. All right, we'll do the same thing one more time just to determine who's critical and who's not. This is a coalition that has all of the players going together here, and if you were to tally these up, I believe you would get 1725. Right, so they have a total weight of 25, and I would start with A, right, because A has 10 votes. So if I lost 10 votes, that would drop me down to 15. So A is not critical. And if A is not critical, neither are the rest of them because they all have fewer votes. All right, so no one is critical here. All right, now this last one, this is the exercise for listing all of the winning coalitions. I would take your time and just start with your largest coalition. So start with your 4-player coalition and then work your way down to the 3s. then the 2s. Okay? So for instance, our first winning coalition would be A, B, C, D with 25 votes. Right? And then I would start with A, B, C, right? I'm going to go down to my 3-person coalitions and I'll do A, B, C, A, B, D, right? And then B, C, D, right? And make sure that I get all of those 3-person coalitions, tally up the votes and see which ones are winners. Okay, so I'm going to pause the video at this point and then I'll get a list here that you can see and then you can compare your list to mine. All right, so there we go. I got 8 total winning coalitions, and you can feel free to check me, see if I missed any. Maybe there's a coalition you think I should have up there. That's fine. Just send me an email and let me know. I do make mistakes, but I'm going to run with these 8. I'm going to assume that these 8 are the only 8 winning coalitions that you can find out of our weighted voting system there. All right, so the next question here is they want to find the Banzhaf Power Index. And to find the Banzhaf Power Index, I have to go through my winning coalitions and see who is critical in each one. All right, so for instance, in this first coalition, we had already found in our previous question that no one was critical in this first one. So I'm not going to circle any of these players here. So we'll go to the second coalition, which has a total weight of 22. Now recall that A had a total of 10 votes, so if A left this coalition, they would drop down to 12, below quota, so that means A is critical. Right? Now A is going to be the only one that's critical here, because remember B had 7 votes, so if I lost 7 votes from my 22, that would drop me down to 15. But 15 is still enough, so B is not critical, and neither is C. All right, now we're going to go through each one and do the same thing, so I'll pause the video again. I will circle which ones are critical, and you can compare your results to mine. All right, there we go. So just taking a look at what we have here, now that I've got all of the critical players circled, I want to count up how many times there were any critical players. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm just going to put that number over here because I'm going to be using that in my power index. Okay, so I'm going to say A, B, C, and D. And then I'm going to count up the number of individual times that A was critical. So I can see 1, 2, 3, 4, 5, 6 times A was critical. So I would say 6 out of the 12 times, which is 50% of the time A was critical. So A has 50% of the power. Then we're going to do the same thing for player B. Now player B was critical only twice. I can see them right here. So I'm going to say 2 out of 12. And if you convert that to a percentage, you should get 16.67%. And then C, same thing. So 2 out of 12. And then D, also same thing. They were critical twice. For 16.67%. Now, notice that when I add those up, 6, 8, 10, 12, that's 12 out of 12. That's 100%. So I want to make sure that my percentages add up to 100 at the end to make sure that I didn't miss anything or add anything up wrong. So I can see my power distribution between the 4 candidates here. And then once we have that power distribution, we can start thinking about different things like dummies and dictators and veto power. We can talk about whether or not this particular setup is fair. So that's what part F is kind of getting at, is you want to try and put yourself in the shoes of each player here. Like if you were player A, would you be happy with this setup? And if you look at my answer key, I kind of talk about that from a couple different perspectives so you can see what I wrote down. Like if I were player A, I would be totally happy with this particular setup because if you look at how many votes A had, right? A had 10 votes out of the 25, which is only 40% of the vote, but I ended up with 50% of the power. Now, player B, on the other hand, player B would not be happy at all. Player B has 7 out of the 25 votes, which is 28% of the vote, but only ended up with 17-ish% of the power. And in fact, B has 7 votes, C and D have less, but C and D still have the same amount of power that B does. So I don't think B would be very happy with this setup at all. I don't think they would think it's a fair share of power whatsoever. All right, so B might be one that thinks we should probably change something with this election. Okay, so that's kind of the way to think about that. Like once we look at that Bonshoff power index, we look at how the power relates to the actual weight that each player has. And as we've seen in many previous examples, the weight of the amount of weight that a player has doesn't always translate to an equitable amount of power. Okay, so then the next part is there any voter that is a dictator? No, there isn't, because no one has 100% of the power. Is there any dummies? Nope. That's because no one has 0% of the power. And then does anyone have veto power? You can't tell by the percentages, but you can go back up to your list of winning coalitions. The definition of someone who has veto power is a player that is essential in every winning coalition. But I have this coalition right here that is a winning coalition, and no one is essential to that one. So that means no one would have veto power. Okay. I wrote out my explanations on the key. If you want to read those, you can, but I'm not going to write them here in the video. All right, the last one here, just dealing with your fairness criteria. And my recommendation to you guys would be to make sure that you go through, hopefully you have these written down somewhere, but they're also located in the book on My Open Math, so you can go back and reread what each of these criterions say. We also discussed them in the notes, and I gave examples of when we violated these criterions, so you can go back and take a look at those. So we'll read through the situation and determine which fairness criterion we did in fact violate here. All right, so in this situation, an election is held with 4 candidates. It says each voter submits a complete preference schedule and the winner is found to be A. So A wins. Okay, but because of a technicality in the voting bylaws, a recount must be performed using the same preference schedules. However, between the time of the original count and the recount, candidate D has withdrawn her candidacy, and the laws specify that in this circumstance, her name should be ignored on all the preference schedules. When they redo the vote, B wins. So A won, and then they did a recount without D, and somehow that got B to be the winner. All right, so this is one of those situations where a losing candidate withdrew from the vote, and somehow that hurt candidate A, who was the winner. All right, and this is a perfect example of the IIA fairness criterion. It's the independence of irrelevant alternatives. If you have an election and you remove a loser from the election, removing a loser from the election should not affect who the winner is. That's what IIA says. Okay, so this is an independence of irrelevant alternatives fairness criterion violation. All right, now number 5, you can read what I have on the answer key. Just create a voting scenario. You don't have to create an entire preference ballot here. Write a story like this. Paint a picture of a situation where the monotonicity criterion is violated, and I would make sure that you could paint a picture for any of the fairness criterion, because if you can do that, you really do understand them. Okay, so think through those scenarios, and you can write whatever situation you want here. There's going to be a lot of different stories that you can tell. You can look at my key for one example. All right. All right, guys, that's it for the review. Hopefully you found some of that helpful. And like I said, I'll be in the Zoom chat throughout the review if you have any specific questions. Have a great day.